Got to give the people, get the people what they want. All right, we are here with some polynomial basics. You are going to get all of this information in your notebooks. You're going to need it for the next couple days in class, and you're going to be able to refer to it. So make sure you get it down. So first you're thinking, well, what is a polynomial? Polynomial is an expression that can be written as a sum of terms. Notice it can be written as a sum of terms. So an example of that is negative 3x squared minus 9x, or x squared plus 4x minus 6, or even just 5x on its own. This is a polynomial. It's actually called a monomial. But notice a polynomial can be one term. But notice it says it can be written as a sum of terms because there's also this other form that you should be familiar with that we're going to talk about later, where it is factored, right? But these factors, if I multiply them out, it ends up looking like these terms that we begin with, okay? So this is an example of factored form right here. This is another example of factored form right here, okay? So polynomials can be in that factored form, but ultimately if you factor them out, they're going to be able to be written as a sum of terms. So part B says, what are the things that can't be in a polynomial? So it's weird. Polynomial is one of those things that's often defined more by what can't be a part of it than what can be a part of it. So there are 6 basic things that can't be a part of a polynomial. First, can't have a radical. So you can't take like a square root or a cubed root. Those can't be involved for it to be called a polynomial. Second, there can be no division if there's x in the denominator. So like this case right here, in x squared plus 5 over 2x, as soon as you get an x in the denominator, not going to be a polynomial. Third, you can't have x as the exponent. EXP, this was talking about the exponent. So negative 5x squared plus 6 to the x power, as soon as you see that, not a polynomial. Fourth, no absolute value signs can be a part of it. So 6 plus the absolute value of 2x, boom, boom, you see this absolute value means we no longer are talking about a polynomial. Fifth, no negative exponents. Right here, 3x to the negative 5th. Nope, not going to work. Can't do it, not a polynomial. As soon as you see a negative exponent. Finally, 6th, you can't have any fractional exponents. 18x to the 4th is great, plus 3x to the 1/5, all bad. Not going to work. It is no longer a polynomial. So, now we're going to get some basic polynomial vocabulary. As I talked about a little bit earlier, we have this factored form. So this is an example of factored form, where you have 3 different factors, right? So x squared is a factor. 2x plus 2 is a factor. X plus 3 is a factor. That's why it's called factored forms. Factors are 2 things that are multiplied together to equal something, all right? So each of these are different factors that gets multiplied together. And from factored form, you can actually create your standard form, which is how your polynomial is typically defined. That is written as a sum of terms, as we talked about. So I'm actually going to do this one out. So first I'm going to take x squared times 2x plus 2, because I'm just going to multiply this through. So I end up with 2x to the 3rd plus 2x squared. So now I'm going to take 2x to the 3rd, excuse me, plus 2x squared, and I'm going to multiply it by this next piece, which is x plus 3. End up with 2x to the 4th, 2x to the 3rd, 6x to the 3rd, 6x squared. And I get my standard form, which is 2x to the 4th plus 8x cubed plus 6x squared. This factored form turns into that standard form. And notice, now we have a sum of terms that fit the polynomial. So an example of factored form we have, an example of standard form we have. Now there's some other vocab. We need degree. Degree is the highest exponent in the polynomial, right? So in this example, the degree would be 4. It's a 4th degree, okay? What else do you need? You need the word coefficient. The coefficient is the number in front of the variable, right? So in this particular situation, your coefficients would be 2, 8, and 6. These are your coefficients, 2, 8, and 6. What else we got? Leading coefficient. Your leading coefficient. That is the number, that is the coefficient in front of the variable with the highest degree. So in this situation, the highest degree is 4, so my leading coefficient would be 2. We got factors, and there's one last thing we need. Let me add a page right here. Boom. The last thing we knew, leading coefficient, we got factor form, standard form, factors. The last thing we need is roots. So let me give you roots. Okay, so roots are usually found in factored form. Okay, so let's take an example. Let's say we have 3x plus 2 and 2x minus 6. Ooh, I just take that all back. That's a lie. Don't do it. Don't do it. Don't do it. Let's go way easier. So you have x minus 7 and x plus 3. The roots are the values, and we talked about this in your exit ticket today. The values of x that will allow the output, right, f of x or y, to be 0. Right, so what are the values of x that would allow this output to be 0? Well, so the roots of this one would be 7 would be a root, and negative 3 would be a root. Why? Well, because if I do 7 minus 7 times 7 plus 3, again, right, I end up with 0 times 10, which gives me y equal to 0. That's what I want. Or it's negative 3, because if I do negative 3 minus 7, negative 3 plus 3, I end up with negative 10 times 0, which is 0. So those roots are the two values of x that allow my output to be 0. Those are the things you need for today. Thank you guys for getting this down. Make sure you have access to these notes for class tomorrow.